process. It is formed as a it is forming as a uh, thin layer on a surface. The finer material which are released from the waste of a rock. The zone it is or the layer it is known as a regolith. We will call that is as a regolith. Yeah, it is involving into the two processes. One it is that in a mechanical weathering, in a mechanical weathering and as well as chemical weathering. Yeah, commonly the process operate together. It's depending upon the local conditions and as well as other circumstances. So either there are two dominated characters are there. These two dominated characters will be working. These two dominated characters, which these only one it is the mechanical fractions of weathering, and the second one it is chemical weathering. Yeah, again, one more weathering type it is there. It is associated with plants and animal habitat or living areas. So that we will call that is as a biological activity. Depend on the plants and animal activities, or depend on the biological activities, the weathered material will be occurred, or the weathered material will be forming. The weathering it is known as a biological weathering. The weathering it is known as a biological weathering, where in a both we can see whether it is belongs to the mechanical and as well as the chemical aspects which are involved. So here the mechanical weathering see, and before going to that again, once we see the rock cycle. In a rock cycle you can see here the magma it is the source. The magma it will be erupted towards the surface and it is a solidified. The process it is known as a solidification, and it is leads to formation of a igneous rocks. It is leads to formation of a igneous rocks, and these material, mm, it is formed in a hardness. I mean, it is having the hard material, or it is having the hard rock type. So, these igneous rocks, whenever which are formed above the surface, and which are getting the weathering and erosion. These two processes. The in the process of weathering only here, just now I told you here three types of weathering process are there. One it is that physical weathering, second one it is a chemical weathering, and third one it is that biological weathering. So, due to this weathering, the fragments are cut down into the small pieces from the source, or maybe it is uh, pre-existing rock like igneous, and those will be moved one place to the another by the transportation method. The sediments are moving on a surface, and they will be settled down in a basin. These are all will be settled down in a basin, layer by layer. These sediments again, and these sediments will be settled down there before the deposition. Then which is a accumulation of a burial material, and more compaction of cement material, or compaction of a cement material, and a dewatering zone, in the presence of a dewatering zone, and which are leads to the formation of a sedimentaries. These sediments, which are utilizing the burial material and the compaction, and later the cementation procedure, slowly it is leads to formation of a rocks, sedimentary rocks. So here, in this process, in a sedimentary rock formations, again there may be a chance which are going to be, again they are going to be weathered. Again, they are going to be either whether this one you see here, this one, the sediment rocks again, which are participating in the weathering and erosion. And here also the sediments again which are participating in or in a weathering process, and later it will become the eroded material which are moved in a certain place, and they will be settled down in a basin. That's one thing. So next come here, the sedimentary rocks which are moving from here to here by the using of a heat, or in the presence of a high temperature and a pressure. Heat and a heat and a pressure. The metamorphism occurs here. So here the metamorphism, I told you yesterday that the metamorphism means meta means it's a form. Morphism means change. The original formation will be changed in the presence of a high temperature and a pressure, in the presence of a high temperature and a pressure. So that here, everything it will be going to be changes, everything it is going to be changes, either maybe it is a texture or maybe structure or a chemical composition or whatever it is, that everything it is going to be changes, and slowly again it is getting the solidification or a recrystallization, so that the metamorphic rocks will be forming. Metamorphic rocks will be forming again, which are utilizing by the high temperature and a pressure under the rock, and they will be uh, again converting into the liquid material, or a hot material, that is known as a magmatic. That is known as a material. That is known as a magma. So this is a, rock cycle which is happening on a within the Earth's crust. Earth's crust. Yeah, later that now we will discussing about the physical and physical or mechanical weathering. Suppose if we can see in a high mountain areas or desert regions, or sometimes it is the areas, the hilly areas which is covered by the ice material. So here the mechanical weathering, maybe it is very dominant in these particular aspects, or in these particular formations, whether it is available in a high mountain or maybe in a desert regions or ice covered areas, their locations or their areas, the mechanical weathering, it is a dominant character. So here the disintegration, it is made up the mode of breaking of rocks, the main, the disintegration is a main part, or a disintegration, it is a main process in the mode of breaking of a rocks. Commonly we can see the common agents, like mechanical weathering. These are the abrasion, uh, frost action, temperature, these etc. Also, these three are playing the very important role in hilly areas, maybe desert regions, or maybe ice covered areas. These common agents are which are useful, or which are working as a mechanical weathering. The second one, it is the most agent. It is that here the weathering. It is most of the that it is a abrasion. In action of a abrasion, the grains which are carried from one place to the another, which is a moving whatever hardest rock maybe it is that. Whatever hardest rock it is, in the process of abrasive action, the grains which are carried the agent, and which are capable the wearing away the hard rock. Abrasion, it is also affects the on the grains themselves, and due to the mutual collision will be happen. The effectiveness of abrasion depends upon their few characteristics. What are they? The hardness maybe and cohesive, and hardness and size, as well as abundance of the sediment material, whether it is being carried or not. And third one, it is velocity of transportation, and the medium of transportation also playing the very important role. The breakdown of a rock into the smaller pieces, which does not involve in a chemical change in a rock. Here we see the frost action. In the frost action due to the expansion of a freezer water. So here you can see here, suppose if you can see, this is a rock and it has a small crack on a surface, and the surface it is extend into the deeper level slowly. As you see, in the presence of a rainy season or in the presence of a rain, due to this rain, the rain it will be fall on this areas, the cracks will be filled by this small amount of water. This will happen in the first year, and later maybe it is a rainy season after that, and in a winter season we can see maybe it is getting the freeze. It is getting the freeze, and continuously what is happening, the rock it is interacting with this water. It is the rock, the side wall of the rock are cracks, and these cracks, whatever cracks are made here, and the cracks it is interaction or reacting with this water molecules, and then the cracks are going to be extend. The cracks are going to be extend. So here the cracks will be continued till end of this boundary, or till this boundary. So again, it will be happen repeatedly and repeatedly and repeatedly, but it is not happening in a 1 year, 2 years, 3 years. More time and more. Most of the time, it will be taken in further. So in further later, after some time passed, these two rocks are broken, getting into the broken. So here it is a separate pieces we can see here. And these two space we can see here. These two separate grains or formed or separate fragments, whatever you call fragments or separate rock formations also. They were formed based on this frost action. Again, you can see here the cracks also. Cracks also you can check here. Along this is the cracks, the material it will be in enter from this one. Yeah, it is entering from this one there. The cracks which are filled, and again this is maybe if it is happening in a first year, and later the cracks were extended. The gaps are filled by this material, and the cracks will be extended or expanded also. It will be expanded. Then later, again the year by year, the more material will be joined here and filled by this material, then it will be divided into the parts. So this is a procedure actually. The frost action it will be done like this. And next one it is, yeah, the again you see here one more example of a alternate freeze and thaw. You see the water or ice particle, whatever it is, that depend on their climatological conditions, depend on the climatological depend on the climatological conditions. See the ice particles which are entered into this cracks and which are getting the freeze, and the side walls or the side um, fractions of these rock material, it is interacting or reacting with this one, and it is getting the weathered slowly, and later eroded that material, eroded that material, and they will be formed in the foothills of a mountain or foothills of a rock, whatever it is, that it is known as a talus slope. It is known as a talus. This material it is known as a talus material. Yeah, you see this. Yeah, again you can see here the rock fractures, huge fractures you can see here, and these fractures are freezed by the water in a rainy season. And here also you can see here these materials also is filled by the water molecules in a rainy season, and later it will be freezed and the cracks were made. You see on a road, on the roads also, like a potholes will be formed, those will be occurred, or those will be formed due to this frost action. Yeah, this one it is a exfoliation. In a exfoliation, the top of the rock formation, as usual, it is same. Yeah, as usual, it is same, but maybe it is occurred the sheet rocks. It is a split. It is a split depend on the expansion, the contraction during the heat and the cooling material were available. So that what is happening, the whatever rock fragments or whatever uh, rock formation, it is attaching with this one previously due to this expansion and as well as a contraction process. Again, it is utilizing the huge amount of heat. Heat. There will be a rapid force will be applied between these rock formation, and slowly it is getting the whether it is expansion or maybe it is in the uh, contraction process. Yeah, this one you can see here the exfoliation where mm, due to this process, the external layer of a rock, and it is removing by layer. Yeah, suddenly the pressure maybe sometimes it is increasing, and suddenly sometimes maybe it is decreased on the surface of the earth. So due to that, the fluctuations at the time, at the same time, the temperature it is also playing very important role. Due to the fluctuation of temperature, whether the rock it is going to be expanding or maybe it has a contraction. Due to this process, the gap, whatever it was formed between the rock layers, those will be those will be extend, or sometimes maybe it is precise. So the rapid which will be done between the two formations. So that is a reason. That's also one reason the smaller cracks will be forming on a surface. See. The physical weathering of exfoliation. You see here what just now I told you, the due to this is contraction and as well as expansion, which in the presence of a temperature and a pressure, the outer layer will be removed. The outer layer will be removed. So you can see here the outer layer, if it is removed, you can see the fresh material will be seen. The fresh material will be seen due to this contraction. The outer layer was removed or collapsed there, and it is getting the weathered and eroded. The material it is maybe formed on a surface nearby areas. The abrasion process. Here the abrasion process, it is a reduction in a size of a rock particles by the rubbing and colliding to the each other rock to the against. So it is the abrasion process. It is caused by the rocks, whatever colliding against to the each other, and as well at the same time, it will be reducing the size. It will be reducing the rise by this rubbing of two particles together. The surface will be removed. The surface will be removed. Then automatically the top layer will be removed by the rubbing of these two uh, rock fragments. So the particular material it will be fall on a surface, fall on a surface, and by the agents of a like wind or a water or a glaciers material which are carried and they will move to the one place to the another. So here, the in the presence of a abrasion, the presence of abrasion means the abrasion process. It is useful for to reduction of a size of a rock, reduction of a size of a rock, and the particles which are moved rubbing by the two uh, rocks, rubbing by the two rocks one to each other. So that due to this reason, the top layer of a rock fragments which are cut down into the small pieces and they will be fall on a surface and uh, in the presence of agents, the agents like wind, water. Water means here the streams like or else rivers and solid water. These will be carried. These will be carried and transported to the one place to the another. So here you can see this one in the presence of a water. In the presence of a water, it is formed as a scrape and grind, and we are away from the rock during the erosion. You see here in the presence of a water, maybe by the agent, if it is worked or the agent as a water, then you see here the surface it is getting the very rough surface it has. And wind it is also you can see here the wind by the wind erosion, you see the material of rock fragments completely the outer layer was removed and the fragments whatever fall on a surface and they will be transported by the wind material or again water material. These will be acting as a these will be acting as a agents. So this is also the here also we can see here it is also wind action or wind weathering. Due to this wind weathering, the base it is stable. The base it is stable, but the top portion you can see here how it is a beautiful structure was formed by the wind erosion. And one more thing, it is the plants and animals are also playing very important role in a physical weathering that is known as a biological. We will call that is a biological weathering. Sometimes the expansion of seeds, which are growing roots, push outward with a tremendous force. The soil, it's creating burrowing creatures, embedded with a small rock particles. In a particular place, in a particular areas, in a particular seasons, the earthworms are especially playing a very important role. Here you see these rats. Can see here the rats. They are creating the hole on a surface. The material you can see the side surface material. It is looking very fine material. And this side also you can see by the plant, the plant's roots. You see here the plant roots also which are useful for to in the process of weathering. in the a role of road plant roads, where sometimes which are getting to the uplift from the rock fractures. So yes, definitely. Suppose if it is a tree, if it is growing on a rock body, what it is the function of plant roots? The plant roots which are penetrate or which are creating the small cracks on a surface of a rock, and slowly through that small cracks the roots will be going to the down. The roots will be going to the down. There the cracks again which are getting the expansion, and the surrounding areas also, the surrounding areas if you can see it is getting the weathered, where the roots are going to be penetrating into the deeper level. And the side picture also we can see, this is the starting stage. Maybe the first picture it is showing the left side, and the second picture it's a completely the rocks were divided into the two parts, and between that the gap the trees we can see here. Trees are there. So this is also one of the cause. It's also one of the cause to leads to the physical weathering. The one next one it is that chemical weathering. And before going to that here, uh, is there any thermal action or temperature changes occur or not? Yes, definitely the alteration of extreme temperature day and night, which is helps to shatter the rocks. Yes, definitely we can say the rocks are not good conductors for heat. Uh, so that what is happening in during the daytime, or due to high temperature and pressure and contract when a temperature, sometimes the temperature if it is a fall, when in the night times the temperature it is a fall, and again there we will getting the contraction, and in the morning time the presence of a high temperature and the pressure it is we will get expansion. So these reasons here, the temperature it's also playing the very important role. And the small cracks which is leads to formation of a flakes are a layer. Those flakes are a layer known as exfoliation. Due to these alternative expansion, the contraction. Based on this, the rock fragments were uh, divided into the small pieces. Yeah, coming to the chemical weathering. The chemical weathering, it is yes, definitely we say this is an alternative process of a rocks. Alternative process means, suppose if we have seen on the physical weathering. In the physical weathering, if it is suppose if it is not uh, the weathering, if it is not happened physically, then we alternate the process. It is there, that is the alteration of minerals in a rock in the presence of high temperature and the pressure, maybe whatever it is, so that the chemical composition maybe it is going to be changes. So for that purpose, the different types of agents will be working. The chemical weathering it is accomplished by the action. Yeah, the chemical weathering it is uh, the action of maybe in the presence of a carbon dioxide, or maybe in the presence of a oxygen, or sometimes maybe these are utilizing utilizing properly, or sometimes maybe it is not because of depend on their availability of these two carbon dioxide, maybe water or oxygen or whatever it is that. Yes, the chemical weathering, which is includes many chemical processes, like maybe it is we can see it is in solution state or solution formation, or maybe we can see it is in oxidation, or we can see in a reduction, or in the process of hydration and carbonation. These five types of processes generally it is involved in a chemical weathering. So the process it is a more rapid and important warm. It is happening in important warm region compared with the cold and hot region. The carbonation we can see here. The carbonation in the presence of a chemical reaction uh, involving by the carbon dioxide or carbon monoxide. Carbon monoxide. So the carbonation will be involved in a biological action. In a biological action. Sorry, please. In the presence of a carbon molecules related, maybe it is a carbonates CO3 or a carbon dioxide CO2, or maybe it is in a carbon monoxide CO. Uh, among these, the carbon monoxide, it will be interacting and reacting more, more and more. In the process of carbonation, the biological activities or biological actions also occurred, and which are taking the help of a hydration, and which is promotes to the very rapidly. We will see here the best example for this one hydration, the feldspars. Feldspars. The breakdown rock material due to the maybe it is chemical change or chemical change in the rock. We see here the feldspar, it is going to be converting as a clay material, or sometimes we sometimes we see the ferromagnetism materials also, like iron. Iron supposed to be reacting with oxygen. So it is leads to formation of a Fe3O3 iron oxide, and commonly we will call that is as a rust material. That is known as a rust material. Suppose example for if you can throw one iron rod at outside, just leave it simply 2 3 days till 2 3 days. Later 2 3 days now you can identify the color change, the brown color. Actually, the brown color we can see on a surface, and it is rough surface it has, and you can remove the rough material from that. That is known as a rust. So here, how it was happened? It was happened with utilizing or reacting with the oxygen molecules and as well as the hydrogen molecules. So that is the reason here the iron oxides will be forming. That's uh, one of the best example for that. And again, we can see here in a hydration process in the same. Uh, Yeah, in the hydration process in the same, where it is the water combination. If it is suppose just now I told you the iron, if it is adding with the water, then the more oxygen molecules will be attracted by the oxygen, and as well as the hydrogen molecules also which react with that one. But it is a uh, released in the form of hydrogen, in the form of a hydrogen gas. Only the remaining material, whatever oxygens were there, the oxygen will react with this iron, and it will release to formation of a iron oxides or iron oxides. So we can see the iron where if it, at outside we can see that iron in a rust with form of a rust formation. Um, The same here, suppose the water combinations, what we have seen in that case, and as well as the clay material, it is also forming nearby areas of a granitic terrain. The granite, if it is associating with a water molecule or reacting with the water molecules, it is leads to formation of a clay. The example for feldspars we can see. The feldspars, the feldspars In the presence of a water molecules, the water it is reacting with the feldspar material, and slowly it will be leads to formation of a clay. See here, this example for this one weathered material here given the picture it is showing by the physical activity or a physical action the weathered it is getting the weathered material, and the loosened material will be formed that is known as the sand it is showing here, and in a chemical action, whereas in a chemical action it is the weathered material, maybe it is a feldspar or maybe it is a mica or whatever, maybe it is that the due to the chemical action or due to the chemical reaction, and that is going to be formed as a clay. Coming to the carbonation. Yeah, carbonation, just now we discussed the carbon and carbon dioxide, carbon monoxide, or maybe it is a carbonates, whatever it is that. The simple example we see here, the carbon dioxide, which is mixing with a water, and it's producing of a carbonic acid. Here it is provided one equation CO2 plus H2O gives rise to H2CO3 bicarbonates were forming. So sometimes the bicarbonates and HCO2 it is also going to be formed, that is a carbonic acid. The carbonic acid will slowly dissolve the rocks and the minerals. It is a strong acid. The carbonic acid it is a strong acid. It has the capability to uh, dissolve the rock, and as well as to dissolve the minerals, where it is reacting the grain boundaries or wall boundaries of rock fragments, and there it is reacting, and the material it will become very loosen. It will become very loosen, and whatever minerals which are having, and it is associating with the or the dissolving the minerals into the with the carbonic acid. Yeah, again, one more example you can see here. The limestone, if it is a hard rock, that maybe it is getting the weak acids. H2O plus the CO2 gives rise to the carbonic acid and H2CO3. The maximum, these are all we can see in a caves formation. Again, you see here the water containing the carbonic acid, and it is a dissolved. All the minerals, all rain water, it is a slightly acidic. The most strongly affected are the calcite minerals, the limestone and marble. Yeah, limestone and the marble. You see the composition, the same chemical composition will be seen in a limestone and as well as in a marble also, but with the carbonic acid and the calcite separate minerals will be formed. Yeah, the same carbonation you can see here, the structure, the carbonate material. It is the best example for this one, stalactite and stalagmites. Stalactites and stalagmites. The stalagmite, it is coming from down towards up. The stalactites, it will come from up to the downwards. Yeah. Yeah, again, the best example for this one carbonation, orthoclase is also best example. The orthoclase chemical composition KAlSA3OH, and it is reacting with the water molecules and the as well as in the presence of a carbon dioxide. So the carbon dioxide plus water molecules, which is leads to formation of a carbonate water, and these carbonate water reacting with the orthoclase and give it is a leads to formation of AlSi2O5, that is known as a kaolinite. That is known as a kaolinite, and kaolinite plus silica plus potassium carbonate. These are will be forming. Yeah, next one it is the carbonation. See here in the carbonation weathering, the karst topography is formed. We see these karst topography in the caves and the convents and as well as sinkholes. The calcium material is playing a very important role here. The karst topography we can see here caves. Here, what is happening? The dissolution of limestone below the water table. Yes, this is a limestone and it is a water table. The solution it will be changes. Next again, through this is joints and sink. These are the joints. See these lines. It is indicating as the joints and the uh, funnel type structures you see here. These funnel type structures are called as a sinkhole. These sinkholes will be formed on a karst topography in we can see in caves and convents. Yeah, this is also you see here excellent convents and caves and sinkhole structure. Yeah, man-made acids. The man-made acids like sulfuric acid or nitric acid, which are produced by the industrial process. The cause of the uh, chemical weathering, which are getting the buildings, statues, headstones, and other structures. Yeah, here you see here in the atmosphere, the water it is associating the carbon dioxide. It leads to formation of carbonic acid and releasing of hydrogen and as well as the bicarbonate ions. The calcium carbonate again it's reacting or reacting with carbonic acid. The calcium ions will be formed and as well as the bicarbonate ions also formed. Sulfur dioxide next one it is the sulfur dioxide in the presence of oxidation state. It is formed as a sulfur trioxide and get out into the water molecules and later it is formed as a sulfuric acid. Again, this is the best example. Oxidation occurs when free oxygen combines chemically with the metallic elements. Yeah, this is Akaras. Akaras. It is showing. This is also this one on rock fragment. We can see here the yellow color portion, and here also the rock fragment, the top surface or surface of a rock. We see that dust will be appearing. Chemical changes and rates. Yeah, climate versus weathering rates. If conditions is not favorable for that, and those will not get any weathering, and they will be weathered by the physical activity or a physical weathering mode. In second stage, you see here moderately physical weathering and chemical weathering is appeared. Yeah. Yes. Yeah, next, we see the transportation. In transportation, the soluble or insoluble material, whatever it is that, those materials will supplied by the weathering and which are moved to one place to the another. The distance maybe it is a different from the origination place. So sometimes they will move very less distance depend on their media or depend on their agents, type of agents which are moved fastly or rapidly and they depend on the force, the fragment material or the fragments which are moved uh, away from the origin place. Yes, here the gravity it is also playing a very important role. If it has a more gravity of minerals, so those will be not sorry, those rocks will be not move very fastly. Slowly they will be moving. So that the gravity it is also playing the very important role. Whether the agents which are air or water or ice or whatever it is, that the transportation material it is a depend on their how it is a depends means it is a depend on that density, or maybe it is a depend on the viscosity and velocity of agent. The materials maybe it is carried out the solution. It is not controlled by any gravity. It's maybe transported material and maybe sometimes the remain material if it is in a solution. So they will be moving. Yeah. Another one it is a deposition. The deposition it's also playing the very important role. The transported material, whatever it is, that it should be deposited. So where it is a specific location, the specific location maybe it is a deposition takes place within the depend on the velocity and then transporting agent we should see, and uh, the changes whether we can see the physical or chemical conditions. If it is a change according to that the material which is moving, or else the chemical changes if you can see that in a chemical weather in particularly it is showing the impacting, it is showing the impacting on chemical weathering, on chemical weathering, so that the chemical composition will be changed. So, example for we see if it is in a chemical weathering, the orthoclase material KAlSa3O8 in the presence of carbonated water, and it is the chemical composition. It is a change. It is showing as Al2Si2O5OH taken four times. It is known as a kaolinite. Complete the orthoclase. Uh, it was changed in the presence of a carbonation or a chemical weathering. Chemically, the material was changed. That's what we have seen, and it is depend on the some of the factors. What are those? The composition of a rock source. It is subjected to the weathering. Must it should be subject to the weathering, and the degree and the mode of weathering that's also playing an important role, and modification and the of sedimentary material that occurs during the transportation. Yes, definitely. And the speed of a agent, just now I told you that the speed of a agent, if it is a rapid speed or a force it is there, the agents will move very fastly, and they are getting the rapid movement on a surface, and they will be settled down very fast. Next, the nature of a amount sedimentary load and its distribution. It is also important. The depositional, what type of environmental deposition it is required? Maybe it is required depend on their influence of some of the complex material, and most of the differentiation we can see in a marine and non-marine or a continental environments based on that deposition site of a deposition. The material it is carried out from one place to the another. The agents are playing the very important role. So here, depend on that velocity, depend on that velocity only mechanically if it is a happen, but there is no change in the chemically. So such type of rocks are known as the clastic rocks or detrital rocks. Yeah, these will be formed. The material, whatever it is, that suspension, it has suspension, and those will be moved from one place to the another. Those will be moved one place to the another, and these formations will be done layer by layer, layer by layer. Each layer we can see it has a one characteristic feature, like color or a texture and hardness. One more property it is that cohesion and composition. Cohesion and composition disposed approximately parallel to the each other. Thus, different beds are formed.